Simulation technology has taken hold across many industries. It has been widely used as a tool for education and evaluation. Seen as an effective tool for creating a lifelike, real-time scenario for learners to apply theory that they've acquired throughout their training. This also allows for a safe environment to make mistakes and the ability to experience a worst-case scenario without damaging effects. We see this in training of emergency responders, professional athletes, and even when the financial stakes are really high. We see simulation across the stock trading market as well. A review of recent literature is central to my thesis. Advancements in the application of simulation technology equip learners with the advanced skills to become workplace-ready, valuable industry contributors. Much of my interest in this topic stems from my current work environment. I'm an instructor in the Artisan Distilling program at Niagara College. Here, in this postgraduate learning environment, we try to establish a number of practical skills to make learners work-ready. This is a high-hazard job. It involves a lot of technical skills and a lot of understanding of chemistry, physics, and even engineering. It's a complex trade that requires learners to enter into the workplace and exhibit safe practices and good habits. Traditional models of simulation technology in practice. The healthcare industry has long applied the socialization of students into professional roles supported by interactions with virtual patients. Not only does this help to integrate the technical skills that are learned throughout studies, but it also helps to develop communication, manage interpersonal responses to the unique diversity of patients doctors and nurses will encounter. This model nurtures active listening skills, quick response time, and the ability to handle complex situations with ease. In a study carried out by Li, Kwao, and Luo in 2021, virtual simulation technology in chemistry curriculum was explored. The recognition of gaps in traditional teaching methods were that it relies too heavily on textbooks, lectures, and presentations by PowerPoint, leading researchers to enrich the experience and explore how to engage novice chemists. Challenges they faced were the difficulty transferring theory to practice, lack of student engagement, and poor performance in true understanding of molecular relationships. Looking at the study of molecules specifically, three-dimensional and rotating simulation helped to develop students' ability to apply knowledge and understand more complex reactions. An intuitive understanding of chemistry can be seen when instructors could deliver lessons that in the practical sense and practical application would be timely to conduct, hazardous, and very expensive. Take this a step further and imagine the integration of VR technology into olfactory detection. In this image, Associate Professor Robert Licmois is practicing on some of the advanced engineering tools coming in out of Arizona State University. These applications are vast, extending all the way to the International Space Research Station. The concept of identifying environmental sensitivities or hazards through smell is very important for my industry and many others. Given the chemistry lab or the distillery, we rely on scent as indicators and alarm. A study performed by Bose and Humphreys in 2021 applied experimental design techniques to study what elements of performance seem to be affected by simulation technology in practice. An experimental group and a control group performed a lab experiment under opposite training conditions. In terms of the time for understanding concepts behind the task, the time it took to actuate the experiment, and the confidence in their performance, the experimental group performed significantly better. While this highly supports the implementation of such technologies into curriculum, it should be noted that performance accuracy was not significantly better for either group. One could conclude that a strong benefit to this technology improves performance and elevates learner confidence. One must ask what the implementation of these technologies actually looks like. Multidimensional approaches are required. Many technical skills must come together in order for this technology to integrate. From the idea phase to implementation, there are many steps in between. It starts with identifying needs and developing a concrete relationship to desired learning outcomes of the students. Further to this, the exploration and adaptation phase identifies developing features that are industry specific. With that, we can't overlook some of the challenges we face. Adopting these new technologies into practice requires a lot of planning initiatives. Our hesitations to leap into this advanced and innovative technology stem from the fact that development and implementation of the software is very expensive. Simulation experts agree it cannot fully replace physical experiments. It's used as a supplemental tool to enhance and enrich. A holistic approach to simulation technology must be taken to deem it effective. Thank you for listening and opening your mind to the possibilities.